My name is Jago de Vreede, and I'm a Java developer currently working for OpenValue. That's a consultancy company based in the Netherlands. And I've been working for Tenet for the last 6 years now, also as a software developer and a Java developer.
And I invited you for this interview because you shared on Twitter a nice screenshot of a JavaFX user interface on top of SDKman. Maybe we should start with what is SDKman?
SDKman is probably the most used SDK manager for Java developers. SDKman gives you the opportunity to install specific versions of Java or even specific distributions of Java on your system, and you can switch between multiple versions as well. So that was especially handy in the era of Java 8 when we migrated to Java 11, for example. Then some projects would only compile on Java 8 and all projects on Java 11. That was easy to switch between those specific versions of Java.
And that's exactly how I use it. So it's a terminal tool. I open SDK list Java and I see all the versions of Java that are available for my system, and I can easily switch between them. But it's, as said, a terminal tool. So you created a UI on top of it. Is it a replacement for SDKman or is it using SDKman?
Well, both. SDKman is only available on the Unix side or on Mac operating systems because it uses Bash scripts to do the switching, and every logic, everything is implemented in Bash. So that works really well if you have Bash installed. But as you know, Windows does not support Bash at all. Well, in the latest version in Java 11, you could use WSL to use Bash there. You can actually use SDKman inside WSL, but then it installs the Linux versions, and then you still don't have the Java version for Windows, for example. So what it does is when it detects, or if it's running on a shell system with Bash, it uses the mechanisms or the initialization scripts of SDKman, and you can actually use SDKman in the CLI alongside SDKman UI. However, like I said, in Windows, you don't have anything that gives you these options. There I've implemented more things on top of what you get in a Linux-based system, that you can actually set Windows path and that kind of stuff inside of Windows without SDKman installed. So there's a separate application. On Unix or macOS side, it is a companion app. You can say that.
So you finally solved the issue that SDKman is not available for Windows.
Yeah, I hope so.
Which is really great. We're talking a lot about Java, but I just ran your application on my PC and I saw that there's a lot more than just Java. Maybe let's just switch to screen sharing and show it, that people see what you created and what you can do with it.
So I can fire up a terminal, and I can say, for example, SDK UI, and then the application will start. As you can see, at the left side, it will list all the things that SDKman UI can install. These are all the things that SDKman itself can install as well, because I'm just scraping the API, just like the Bash API will do. So everything released to SDKman will be available in SDKman UI. Now, this is a quite big list, as you can see.
And I already see as the first thing is Maven. Some people have issues installing Maven and setting the path variables and stuff like that. So they can also do that with SDKman.
Yeah, as everything will be set up correctly. If you install something the first time, like for example Maven or Java, it will also add the Java home or Maven home environment variable as well. So other applications can actually use that environment variable and point to the correct version. So that really helps installing and making everything easy for the users. So if I click on Maven, you will get a nice list of all the versions of Maven that are installed or available. It's a quite long list, and even the beta versions you can install.
And I see you have 4 versions installed on your system. So you're one of those developers switching between even Maven versions.
Yeah, or just not cleaning up old versions.
Which also happens, yes.
So that's the usual path that I take. I install a new version, check that it works, forget that the old version is there, and it's still here. So I can actually remove that. For example, this version is 391, and it's gone. It's that easy. You can also do this on your Unix system with SDKman, but that involves a lot more typing. So you have to do SDK. Um, I think it's uninstall. I actually never used the SDKman to uninstall anything, but you can use U or uninstall Maven and then the version. But this involves more typing, and this is a lot more convenient. Um, and that's probably also the main reason I created this tool, because well, it's all fun and fun in games if you do stuff in the terminal. It's very handy, but the Java listing is quite long. So if you're looking for a specific version, I mostly use grep then to figure out the correct identity for that specific version to install. Well, that's a bit of annoyance. So having that entire list here, just scrolling down to the version that you need, just clicking install, and you're good to go.
Okay, this looks really great. Can you maybe show some of the code, something which is specifically a solution for what you're trying to do with SDKman?
Yeah, sure. Let's go through the flow of installing an application. If you download an application from SDKman, it will usually download a tar.gzip or a zip file. But SDKman actually caches all the installations on disk and first repackages these to a zip file, and then extracts that zip file to the target directory in SDKman candidates. However, there are some quirks in there. So maybe let's go dive into installing that application. So first off, it was controlled to download something. This is also one of the things that I ran into. I was trying to update the download progress in the UI, and the download is actually being done on a separate thread. But if you want to update the UI in JavaFX, you have to call the platform.runLater, because you can't update the UI outside of the JavaFX threading. So you have to put it on the JavaFX thread. But if you're downloading a file and, well, every 8 kilobytes or something, you update the UI, then the UI threads gets really, really overwhelmed. So that's some trickery as well. So I'm not updating that progress every iteration.
Every
Just
step,
So I'm calculating if the progress has at least incremented at 1%, and then only update the UI. So I'm calling install here. Then I call the api.install. Then we're actually inside the installation. We have a zip extraction task. So we can extract the file that we've downloaded. We're going to download a file to a temporary file, because if the download fails or whatever, we don't want to have a broken zip file or whatever on the system that we do not know the state of. So it clears out the temp file and then creates it. And then we're going to install it. Then we're going to extract that temp file. But if I go to the extract function, you might see something not there or there. And that's the process starter. I don't use the Java native extraction or zip libraries, not even the Commons IO compress library as well, because those cannot handle symlinks. And on Unix systems like Linux or macOS, there are some symlinks in JDKs. And that's quite annoying if you want to extract them, and that really goes wrong there. So what I just use is just the native zip and tar and that kind of stuff. So I just start the unzip executable. You can actually configure that inside of the application. And maybe this makes sense why you can configure that as well. But it uses that zip, so you don't see any progress. You see just a spinning bar. Shouldn't take that long, and then it's done.
Is this something you think where you make full use of Java and that it works across platforms, that you can have the same code now for your Windows environment and for a Mac environment, Is that one of the main advantages you see for Java and JavaFX in this project?
Yeah, absolutely. Because the main advantage of Java, indeed, is that it is working cross-platform. So Java is the programming language that you write once and run everywhere. Um, that holds true if you're using Java. However, I took the insane approach of trying to create a native binary because, well, you have GraalVM and you can actually create a native binary from Java. So how hard can it be, right? Because if you have a native binary, you don't need to set up the entire JDK for this specific tool. You can actually bundle the JDK with your application. That's also a viable solution. That involves a lot less work, I can say that. But creating a native binary gives the users an opportunity to just to run the application and that's it. That also gives me the opportunity to do auto updating, for example. So I can actually go to GitHub and download the latest version and install that, or just copy it to the correct version or to the correct directory, and there you have the new version. So you don't need to figure out on which JDK are we. Do we need to update that JDK as well, or do we download everything? It just makes my life in that sense easier. But well, it gives me headaches on other places as well.
So the step going from your compiled jar to an executable for each platform, that's where GraalVM comes into
Yeah,
place.
that's what
And,
GraalVM.
and that's where you've. But on the other hand, this is an open source project, so that means that everyone who is struggling with this same thing can now see how you did it, because this is all done with GitHub Actions, right?
Yeah, this is all done in GitHub Actions, and I can actually show you that because it's also in this code as well. So I have a early access and a release. Well, the early access and release are the same, more or less. It just does some sanity checking and then some magic with POM files. But the magic happens in the assemble native. If I zoom in here, you can see the matrix of the GitHub Actions. So I'm running on a quite old version of macOS 13. I can't go to the latest because that's an M processor on GitHub Actions. We have the Windows latest and Ubuntu latest, so the Linux versions. I'm trying to support two architectures or CPU architectures. Currently, I only have access to the x86 versions, so I can only test the x86 ones for now. So that's my main focus. So although I have a JDK arch here, I'm excluding those in every single version as well. And then I need to set up specific things on specific environments. So for Windows, I need to add msbuild to the path. Well, that's just something, there's a GitHub Actions plugin for that, so I can use that. But it only needs to run on Windows. Then the Windows Visual Studio Shell needs to install on Windows. And then we come to Ubuntu or Linux. Then we need to install a lot of libraries in Linux as well. A lot of things are specific for JavaFX that I'm not going to use, but we still need them to build our application because, well, it still needs to link to that. And, well, we'll figure out later that it won't need them, but it will complain beforehand that there aren't there. Yeah. So, and for macOS, we need Xcode. So then we can install the Gluon GraalVM. So I'm not using the plain GraalVM for now. I might look into that someday to figure out how to build it on the normal GraalVM. But the Gluon GraalVM has some additions to it. So it has something called substrate. And in that substrate are the shared libraries that are needed to build a JavaFX application.
Yeah.
If you don't have the substrate, you run into the issues that you can't link or cannot build the JavaFX applications correctly. Then the normal checkouts, then the normal caches, except I'm also caching the substrate because that's downloaded to the home folder .gluon. So let's say 80 megabyte zip file that's being downloaded. I'm just calling build Maven, and I'm sorry, I'm calling install here. I really am. That's because I have two separate projects, the API and the bundled software, and those projects do not know anything about JavaFX. So the next thing that I need to do is call the GraalVM compile, and I only do that on the JDK or for the UI project, so that this project. But this project has dependencies on those two. Then comes the fun part. I need to remove some stuff. So I compile the GraalVM application. However, like I said before, I do some magic with Windows to set the environment path, for example. As this is a very restricted Windows laptop, I'm not allowed to execute the rec.exe. Normally, it would set regresity items using rec.exe, but those regresity items are necessary to put in the path, for example. So I'm making use of a GNDI library that actually calls the Windows registry underneath, but that's a Windows-specific library that won't work on macOS or Linux.
No.
So I have to remove that library, because if that library is there while linking, it will fail on macOS. On Linux, I've seen other issues with it, so I just removed it, and that makes my life a hell of a lot easier. It will give me a warning that the file isn't there, but that's fine. It will continue, and the linking is done after that. So then I can just call the link. First, you create with the compile. You create your shared library, or whatever that's called. It's just the stuff that's gonna be inside of the binary, and link is actually gonna create that binary for you. So the specific version on for Windows.
I have seen these being called in one command, so GraalVX compile and GraalVX link, but you need to step in between to do the cleanup, I guess.
Yeah, you can actually call GraalVX build. That will actually call, compile, and link right after each other. So there's no need to reinitialize Maven. But like I said, I need to remove these. So and then I just zip it, upload it, and JReleaser takes care of the rest and uploads it to the website. So if I go to the GitHub page, there is actually a early release as well. So it will upload the binaries from the main branch build to this early release version. So that's quite handy. So I can actually download this from the website and figure out if it's actually working. That's quite nice.
So the early releases are always up to date with your latest commits.
Yeah, so I've got stable builds as well. So if you go to the GitHub page itself, you will see the latest release here. So and that's actually being used if you auto update as well. So I can actually show you auto update. That's also quite fun. So if I use the early access and install it, you can also see the installation process here as well. So if I open that zip file, I can just call that application. Then I'm not a publisher yet, so Windows is complaining here. So I say open anyway, because it's me. And then it will ask you to update SDKman UI, for example. You can just click yes. It says been updated.
So you integrated the update and installation process in the tool itself.
Yeah. So that makes the life of the developers that want to use this tool a lot easier.
Yeah. An earlier video in this series talked about jDeploy, which takes another approach. There you have the installer and updating it separately, which is, it's two different approaches. And it takes care of installing the Java, but as you said, it indeed needs to check if it is the right Java that is on the system and stuff like that. With a native application like you are creating, you don't need this step. It's just an executable.
Yeah.
It contains everything. Yeah. So we're now looking at a Windows machine.
Yeah.
Do you also want to show this on another machine, Mac, Linux?
So we're now on a Mac system. So here is also SDK installed. So I can do ls Java, for example. And here you can see the entire list, and well, it's quite a big list. And if you're looking for a specific version, well, if you quit out of it, you lose your visuals. So that's kind of annoying. So that's why I use the SDK UI. And here's also a update available because it's still running on the bit older version. It doesn't matter. So if I do a ls Java, I can see which versions of Java are installed. I have a lot of installations here. For example, if I say I want to use this version, so the 23 Amazon, I can use SDK U Java that one. And if I call java.version, I'm using Java 23 and this one. So if I call SDK UI, I can actually see that UI detects that I'm using the 23 Amazon in this shell, but my global version is set to the 22.1 Gluon version. So it detects that there's been change in this window, and I can actually change it here to a different version as well. So I can actually say I want to use this 17 Amazon here. Yes, and close, because then I'm out of the application directly. Then if I do a java.version again, I'm now in the Java 11 version. So that's quite nice.
I looked into the code, and I see you've taken another approach than I do with JavaFX. I program every component you see. I go from the code first approach. I want to construct a button in my code. I see that you are using FXML. Maybe you can show it how the layout is created
Yes.
of the UI. What is the reason that you prefer or use FXML?
I'm not really that great of a UI designer or whatever. So having an editor that will show me what it looks like, and just by dragging and dropping, or just taking something bigger and see what's not working, what is working, uh, gives me an advantage of doing that in code, because if I made something 10 pixels wider to see if it fits, then I need to recompile the application, start it up again. It's fast, but it is not instant. There's an application called SceneBuilder, and SceneBuilder is actually what you see is what you get editor for JavaFX. So I have, for example, my main.fxml. You can see here the UI. It's empty and it shows loaders because there is no data. But I can actually drag and drop this little thing and see what it looks like. So do I like this or not? Well, that's a lot easier than doing this in code. It's quite handy for me. But as you can see, I only have two buttons here, the Java and Maven versions. But in the real application, you see a lot of buttons. That's because these are only are only available in the FXML, and in code, I'm recreating new buttons and placing that into this view. So that's really how that is done. So I'm mixing and matching wherever what seems fit, but this is just easier for me to see what's going on and what it looks like.
Yeah. So the main advantage for you is this scene builder, that you really see what you're creating as user interface instead of needing to run the application and see what you have been messing up in the code.
For example, these kind of things, I wanted to have to be on the curve, just touching, but not over. So that's really figuring out which kind of pixels, and that's quite easy if I can do this. Just this looks great. Okay, so that's good. So it's just faster for me. If I wouldn't have the scene builder, I would definitely be building it from the ground up in Java, probably like you. But the scene builder is giving me so much freedom.
And it's a tool which is maintained within the JavaFX project, so it is up to date also with latest JavaFX versions.
Yeah, absolutely. So
it already looks great. It runs. Everyone can use it. Can check its sources. So, what are the future plans? Are there any bugs to solve? Features to add? Do you want help from others?
there are a lot of bugs to solve. Like I said before, it's just being made in some spare time. So what I really want to do is create some tests for these applications as well. But I'm currently looking for a framework or something that I can actually test the native version of the application.
If people have experience with this and they want to help you, they can do, because it's a GitHub project. The
This
link to the sources will be below this video, so
Yeah.
can people find it easily. Okay.
Yeah, so if people want to help clean up code, they're more than welcome to happy to do so. Well, if you find any bugs, please raise an issue. Even better, make a PR and fix it. But a issue would help tremendously as well. So that would be great.